Topic of volumes of revolution, and it's basically when we have a function like y equals e to the x, and we have constraints, and we want to rotate it about an axis, we get some kind of 3D shape. And we when we get a question like this question has right here. So the first thing we do is we want to draw a graph. So we would just draw a graph nice and neatly on the side. Okay, and we're gonna plot this function. It's usually just pretty simple to plot. You can put in numbers and you'll get an exponential graph like this. This is y equals e to the x, and we have certain constraints. Y equals 0, so over here, right here, y equals 0. We have x equals 0, so this right here, and then x equals 1. Let's say this is 1. We're going to put right here. This is going to be a constraint as well. And this is about the axis y equals -1. If this is -1, this axis right here is where we're going to rotate this area about. And basically, first step to go about this question is we know that there are two radiuses because it's going to make a 3D shape. And what I would do first is, everyone should know the formula for this is b to a of pi of the outer radius, which I'm going to do that, outer radius squared, minus the inner radius squared with respect to r. Right? So this is the formula for doing volumes of revolution around an axis with a hollow center. So we're going to start by, the first thing I usually do is I usually write an outer radius and an inner radius first. So we will have, so like this, I'm going to use a different color. I'll use blue. We're going to have an outer radius. This is going to be our outer radius. And we're going to have an inner radius. And after this, we know now we have an outer radius, but what is that outer radius? Basically, over here we have e to the x, and over here we have a 1, right? The distance from here to here is 1. And same thing here, all we have for the inner is just 1. So setting up the equation, we know it's from b to a, in this case it's from 1 to 0, so we're going to write 1 to 0 of pi of the outer radius squared. Outer radius is just e to the x plus 1 squared, subtract the inner radius, which is just 1 squared. And this is with respect to x. Now we can simplify this and integrate, and then basically what we get is we gotta open this up, and we should get e to the x plus 1 minus 1 e to the 2x plus 2 e to the x. That should be our, when we open the inside up. And basically now this will cancel out, equals 0. And we now, our function lies like this. 1 to 0. We can take out the constant pi, and we can get a function that's known as 2e to the x, right? Plus e to the 2x dx. Now we can integrate. Basically integrating this, we can take out, this usually integrates to, we can split it up so we can get, this is all multiplied by pi, so we can split it up, 2e to the x plus the integral of 1 to 0 of e to the 2x, all with respect to dx, and this is just e to the x, right? So this is 2e to the x plus, whenever we take the e to the 2x to a power, we just want to divide by 2, and we get e to the 2x over 2, all this times pi, evaluated at 1 to 0. And basically that just sums down to pi times 2e to the 1 plus e to the 2 over 2, subtract e to the 0, so we get subtract 2 plus 1/2, and this is going to give us our volume. Simplifying this out, we can get 2e plus e to the 2 1/2 minus 2 minus 1/2 times pi should give us our volume of revolution around the axis y equals -1.